ratio. So a ratio is a comparison of two or more quantities. They are separated by a colon. I'm trying to read that, isn't I? And it says one quantity to another. So for example, we're 80 girls and 100 boys at a disco. Write this as a ratio of boys to girls. So notice I've written the words boys to girls, just so that's in my head clarifying what's going on. 100. What number would I write under this side? 100. Oh, you didn't fall for it. Such smarties. And then I would write 80. Oh, lovely. Yeah. Right, okay. So you don't have to simplify, but we are going to go on to simplifying as well. Just read the question, essentially, is what I'm going to say to you, to check to see what format they want to. So, order is important, you must read the question carefully. If writing quantities in a ratio, they should all be in the same unit in order to compare them. So often they will give you it not in the same unit and expect you to change it. So this is where conversion is really important. And you need to remember that. Have we been through conversion? No. No. Okay. Do you remember conversion? No. But quick sidebar. My suggestion is this is the chart you need to remember. So we've got millimeter, centimeter. Oh, that's too many. Meter and kilometer. Yes, that we all know that there are length measurements. Now, secretly, this same chart could be for a gram or a litre. Oh, does it go like 10, 100, 1,000? Yes. So this, you can have a milliliter, milligram, centiliter, centigram, kiloliter, kilogram. Okay, so this same chart works for all of those three base units. The M is for length, the L is for volume, the G is for mass. So my chart, so if I'm going from a bigger unit, converting it to a smaller unit, do I have more of these in there? More. Yes. So that means I'm going to be multiplying. Okay, so from the bottom, on my chart, the bottom one will all be multiplied. What would the top one be? Right. Oh, that's the wrong sign. And we've got 10, 100,000. It's a cinchy chart. Bless you, it's really allergic to. Oh, okay, that was a whole different question with lots of hands. Only one person stinks. A few more allergic. Alright, obviously if you're going from a milliliter to a kilometer, you're going to check how many zeros there are. We're going to go all of them. Well, if this is something that you are not crashed up with, then potentially yes. Subway. Right, okay, so the amount of flour is 1 kilogram for every 300 grams of butter. Right, that's a ratio of flour to butter. So first of all, flour, I've got 1 kilogram, and butter, 300 grams. And do you want them in kilos or grams? I don't care. I'm going to go grams simply because I can take our numbers and not decimals. So what would I change this left-hand side to be?
You have to multiply it.
Multiply it by... Okay, so I've got 1,000 grams and 300 grams. As soon as you now have the same unit, you can drop the unit. Okay? If you left it, that's fine. But I'm just saying, if you don't see a unit there, it means that they are representing being in the same unit. And then maybe three quantities compared. Bless you. Bless you. I know, I mean. So that ought to be 10-3. 10-3, yes, because we use simplified it. So, yes, just three things. So Sarah, Jennifer, and Shelby shared some candy. They were allowed to have a candy in the ratio of number of letters in their name. So Sarah, how many candies did Sarah get? 5. Jennifer?
7.
9. 1, 2, 3, 4, 5, 6, 7, 8. We have 7 and 9. And 6. Okay. Ideally, the values should also be written as whole numbers. So a recipe calls for 1.5 cups of flour and 2 eggs. Now this is where the tricky thing is, because I've just said that it's in units, but obviously a cup and an egg is.
Well, you even measure flour in eggs.
But you catch the drift, don't you?
Oh, yeah.
Would you not? Would none of you actually said that? I shouldn't have mentioned it, should I? And then I could have just glossed over it. But anyway, 1.5, 2 eggs. Need whole numbers, so what do I have to do to it? Okay, so you've got a couple of options actually. This one's nice because it's a 0.5. So as Hannah said, to make it a whole number, I could just multiply it by 2. But I have to, it's the same rules as fractions. Whatever you do to, well, it's the same with anything now. Whatever you do to one side, you must do the same to the other. So if I multiply this side by 2, I would get 3, and oh my gosh, that really isn't 6. Good maths, Good maths. So I would have 4. However, if it was something more complicated like 1.3, not quite so easy. So how can you get rid of any decimal value? Multiply 10. Love it. So we could have gone to 15 and 20 and then reduced it in the way that we're going to learn in a second. Okay, so you've got a few different options, just be aware of that. Christiane?
Wait, why didn't you do 1.3 times 2? And then 2 times 2?
Because 1.3 does multiply 2 does give you a whole number. So ideally, yes, whole numbers are. Now, some questions your answer will not be a whole number, but that's because they've asked for it specific format. Okay? But generally, whole numbers. Okay, good. I'm going. Oh, yeah. Oh, because as I said, if it wasn't nice, like 0.5, well, it was obviously multiplied by 2. So had this said 1.3 to 2, then I wouldn't have just been able to multiply it by 2. So to get rid of any decimal, you can multiply it by 10. So this would become 30 and 20. Oh, thank you. Yes, good.
We have to simplify it or leave it?
Well, again, yes, probably simplify it, but I'm going to go through that now.
So we just
Yeah.
I know that's not.
But yes, this is something that some people are like, oh, I don't remember anything with added double ratios. Obviously, you are recording.
So it'd be the same thing.
Alright, so there are different ways of writing ratio statements, so you just have to be careful when you're reading the question. They can be sneaky sometimes, so you just, like, I can't encourage you to do anything other than read the question carefully and make sure you're not just gut reaction, looking at something and jumping into the question thinking you know what it says. So a shop has 8 customers, 6 of them are girls, the other 2 are boys. So you've got several different ways of talking about these people. You can have girls to boys. So generally it would be written as a colon. You might see the word 2, less common than it could be. It could be boys first, so it would be 2 to 6. It would be girls to the total number of people. So that would obviously be 6 to 8, or boys to the total number of people. So you can have any kind of combination of these things. I'm just trying to make sure that you're aware that you must read the question. Simplifying ratios. And so in many cases we'll be able to simplify the ratios. You do this similarly to simplifying fractions. In other words, you're finding a value that divides into all of the numbers. Okay? The trickier one comes in when there's 3 numbers. Let's try and find that. But it's the same principle. Your calculators can help you, especially if you've got the little baby ones still. And you can just put it in as a fraction, press equals, and it will simplify it for you. So, but let's not jump straight to the calcs. 15 to 25, what number goes into both of those? 5. So you're going to divide both by 5. And you're going to have 3 to 5. Okay, I like to write it underneath, and then I tend to show what's happening to the side. So 15 divided by 5 gives me 3. 12, 3 and 9. What number goes into 12, 3 and 9? So we're dividing all of them by 3. So we'll have 4, 1, 3. Trivia. 10 to 4. 2, so we have 5 to 2. Yeah? And you're back to the next ones. I should pause for now. I'll be right back. After this break. Oh no, no, it's still going. Okay, so there are the answers there. So D was no, 75. Oh, should I just keep going? Yeah, I think it's alright. Okay, finding missing ratios. So in some questions you'll be given 2 variables and told the ratio of them. You'll be giving it a new variable for one of them and asked to find the other. So to make cake, sugar and flour are mixed in the ratio of 1 to 3. If you've got 1200 grams of flour, how much sugar do you need? So I started off my question by talking about sugar to flour. So I'm going to write 1 to 3 because that's the ratio it's been given. 1 to 3. Yep. So if I have 1200 grams of flour, I'm going to change this side to now say 1200.
Oh, so it has to be
Okay.
100 to 3 divided by 4.
Secretly, how did I get from a 3 to be 1200?
Times by 400.
So you would multiply that by 400. Oh my gosh, that is 400. Not for the linear thing.
How do you know that the...
Because my question says I've got 1200 grams of flour, so that's why I put it on my flour side.
Oh, because it says...
Yeah, and that's why I always put, actually, there's stuff at the top. I may not always write the word sugar flour. I probably put S and F. But I would always actually just in my head or make sure I've got it clarified which order I've got it.
Yeah. So the way they're written in the question is the way that they
Yes, and again, it probably would say respectively or something because they said the word sugar and flour first. So they probably would give some other indication that that is the order that they talk about. But if not, assume that. If they don't have anything, just assume that that is the order. Okay? So we would multiply this by 400, so therefore we would have to multiply this by 400. And gives us 400 grams. So how much sugar do we need? 400 grams. Synergy, yes? Remember what you do to one part ratio because it's the same to the other. You'll always be either multiplying or dividing. Dividing into given ratios. So you may be able to divide amounts up or divide amounts up into given ratios or split amounts up into given ratios. Doris and Betty buy a raffle ticket and they win the top prize of $1,000. The ticket had cost $2, but Doris only had 50 cents to buy the ticket and Betty paid the rest. What portion of the prize money should Doris receive? Well, in these it's a lot of words. We need to take the information from this. So I've got Doris and Betty. So how much did they actually pay for their ticket? Doris paid how much? 50 cents. And how much did Betty pay?
Well, it's
150 cents. Yeah, so we'll keep it in the same unit. Let's simplify this so I've got it in its smallest version. So what's my smallest? What can I divide it by? Divide by 50, yeah. So that becomes 1 to 3. You ever happy with that?
Wait, where did the 50 come from? I mean, where's the 150?
Because if the ticket cost $2, then Betty must have paid $1 because she paid the rest. Yeah, so I've just now simplified it to 1 to 3. Yeah, you all happy with that? Why divide by 50, both sides. Yeah. Alright, so you've got 2 ways of doing this. You choose whichever method you like. So, method 1. I say, if I've got, Doris and Betty are in the ratio of 1 to 3. So in total there are 4 parts. Yes? Oh my gosh. Hang on. All right, so Doris and Betty, so we've got 4 parts total, yes? So what we can do is we can find the value of one part. And we do that because we've got $1,000, and we would then divide that by 4. You all happy with that? So 1,000 divided by 4 is $250. So if Doris only paid one part of the ratio of the ticket, that means that she should only get one part of the value back. So she would get $250, and Betty would get $3 for $250. So that's 250 to 750. Just be careful, answer the actual question. So if they've said how much money did Betty receive, you would just need to say $750. If they said how much did they both receive, make sure you list it as to how much they both got. Second method. Good. So second method is very similar. We still need to, oh my gosh. We still need to appreciate that there are 4 parts. So that means that Doris is 1/4 of it, and Betty has 3/4 of the amount. You all happy with that?
Yes.
So that means that Doris has 1/4 of 1,000, and Betty has 3/4 of 1,000. 250 and 750. Okay. So you get the same answers. Some people prefer to just find the value of one part. Some people like to work in fractions. You get to choose which method you prefer. Okay? And that ends. No.